on top of unit circle projects being due next week, we also have a summative a week from today. So next week, Tuesday, will be the summative. It will be a two-parter. It's a calculator, non-calculator type of test. So you'll do the first part, and then when you're done with the first part, then you can get your calculator up and start the second part. Okay. We also went through and we figured out what all homeworks that we are going to be collecting. Now remember that it is, so there's been a little confusion, and there's confusion every year about this, and don't feel bad that you're confused about our crazy homework policy. But so if your grade is below an 83%, you have to do those 7 worksheets. Okay? You have the 3 trig worksheets. The SOHCAHTOA word problems worksheet was from last week, Friday. The reference angle practice worksheet you're going to get today, and the review you're going to get on Thursday. Okay? So those 6, I think I said 7, those 6 worksheets are due for if you're under 83%. If you're over an 83%, you still need to do those. You just don't have to turn them in. Okay? But you should still be doing them. If you decide that you want to do them and turn them in, by all means, you can turn them in. You'll get points on them. They'll be graded just like everybody else's. Okay? But you just have that option of not turning them in, and they'll just go in as an X, excused, in the field. Okay? But if you turn them in, they'll be graded like normal. You'll get points for them. It'll go, it'll benefit your grade and all that fun stuff. Okay? Okay? So that's that. Any questions on that, on the turn-in? Because this is the first chapter that we have. And then second semester, we'll get some grades. You'll get some grades built up in the grade book, and then we'll put the same policy in place. No? No? All right. Awesome. So today, then, we're going to take notes. Unfortunately, there's a lot of slides, but there's not a lot of actual note writing type of things after the first few. Okay? But there's 1, 2, 3, 4, 5, 6, 7, 8, 9 slides. But there's not a lot of writing that goes along with the word. So we'll be good there. Okay? So let's talk about angles in standard position first. We need to come up with a definition of an angle in a standard position. But even before we get to standard position angles, let's talk about an angle. Okay? So an angle, you may think is just that. It just looks like that. That's all it is, right? But there's actually 3 distinct parts to an angle. The first part is this one right here, and that's called the initial side. So that's the initial side of an angle. Then what happens is something rotates around this point here called the vertex. And it can rotate in either direction, clockwise or counterclockwise. Okay? And so what happens is that gets rotated around there, and then once you reach that angle, it stops. And when it stops, it's called the terminal side. That S. Let's fix that S. Yeah. So the measure of an angle, is the amount of rotation from that initial side to the terminal side. Positive angles have counterclockwise rotation. Think unit circle. Right? We start out here at 0 and we go counterclockwise. Okay? Now, you guys are living in a digital world. You probably don't remember an actual analog clock. We used to have them all in every room in the school, and it was awesome. Okay? But now we've got digital ones because they said that they were all the clocks that we have the same time. You know, so selfish. Okay? Right? Negative angles have clockwise rotation. I was talking with my new British friend, the guy that plows my fields for me. His name is Glenn. He's literally from Great Britain, but now he's over here plowing fields. And he's like, do kids still know how to read a clock, an old clock? And I'm like, we talk about it every day in pre-calculus. Why do we call it clockwise rotation? Yeah. Huh? Now, you're saying to yourself, Lynn, why do we have to know all of this stuff? Well, here's why. Okay? We can finally now get to the definition of the standard position of an angle. Okay? There's two classifications, qualifications, conditions, whatever you want to call it, for an angle being in standard position. The first one is the vertex must be at the origin. So that's the first. Your vertex has to be at the origin for it to be in standard position. Second condition classification is that the initial side is on the positive x-axis. Okay. So if this is my Cartesian coordinate system, whatever you want to call it, the angle, the vertex, has to be, oops, now let me get my colors back. What we call it, green was vertex. Okay, so my vertex is at the origin. My initial side is along the positive x-axis, and my terminal side is somewhere else. And so if I wanted to measure this one in a positive manner, I would have that as my positive angle, or I could have that as my negative angle, both in standard position. Okay? Next topic for today is something called a coterminal angle. Now let's take that coterminal word and let's break it down. What word do you see inside of it? Terminal. Where did we just learn about terminal? In an angle, right? Okay, right? So if we throw co on there, what do you think that co is going to stand for? Part? Like coincide, so like multiple ones, partners, okay, partners and stuff like that. So let's just make yourself one. Let's draw ourselves a standard angle. I'm just going to put it anywhere. It doesn't matter where it goes. Let's say that this angle here is 50 degrees. Okay? 50 degrees. Now, a coterminal angle is any angles that share a terminal side kicker here is in standard position. Okay? So I'm going to give you one, and then you're going to give me more. Okay? I'm going to give you another angle here. I'm going to make it green, and green is going to be 410 degrees. Is coterminal with 50. Here's my 410 degree one. They're two different angles, but they share, when in standard position, they share a terminal side. Give me another one. What? Nope. With 50. Another coterminal angle with 50. Sorry, I was unclear in my direction. 770. I'll do red on that one. Oops, I went the wrong way. There we go. 770, you said? So that's going to be 2 laps around. What do you got? 1130 would be the next one. 3 laps around. Be a negative one. Negative what? Not negative 410. Negative 310. Sadie, you look confused as how we got to negative 310 degrees. Taking it in. Okay. Well, I'm going to explain it. Okay. So if I go around the circle in the wrong direction, I still go 360 degrees to go all the way around, right? But now it would be negative 360 degrees. But if I take off the 50 that I had, then I'm only going negative 310. Okay? With me? Love it. I think there's anything more on this slide. Oh, maybe there is. Find and draw a positive and negative angle that are coterminal with those two given angles. Go. So I got negative 150 degrees is out there. Yes? Okay. So these are not the only ones that are coterminal,
but here are three of them. 210 degrees is a positive, 570 degrees is a positive, 930 as a positive, 1290 as a positive. A negative. Negative 510 degrees. Negative 870 degrees. Negative 1230 degrees. Negative 1590 degrees. Those are your first four positives and first four negatives. 2 pi over 3, that's up here. So a positive angle for that one would be 8 pi over 3, 14 pi over 3, 20 pi over 3, 26 pi over 3, 32 pi over 3, etc., etc., etc. A negative would be negative 4 pi over 3, negative 10 pi over 3, negative 16 pi over 3. All of those angles are coterminal with 2 pi over 3.
Questions, comments, didn't get any of those.
Awesome sauce. Okay. So, I want to find theta if the terminal side of theta goes through the point negative 3 comma negative 2. Okay. So the point negative 3 comma negative 2 would be down here. Agree? How can I find that theta?
You have to find where the line where
Nope, wouldn't have to. The only way that we can find an angle right now, as we said. Make a right triangle, right? Okay? So let's make a right triangle. Right? So this side up here would be negative 3. This side over here would be negative 2. Right? How am I going to find theta? Nope, that would give me the other side. Tangent, right? So the tangent of theta is equal to what? 2 over 3? Or really it's negative 2 over negative 3, but it reduces down to 2 over 3. Okay? All right. So how am I going to find theta? Inverse tangent? Yep. So inverse tangent of 2/3. All right. Everybody with a calculator. Inverse tangent, 2/3. What do we got? 33.69 degrees. Right? Is that my theta? Why not? Why? Because theta is over here, right? Is that an acute angle? Is it even obtuse? It's great, isn't it? It's actually what it's called. It's called a great angle. Angle bigger than 180 is called a great angle. Okay? So, something's not stirring the Kool-Aid there. Alright? So, let's go down here. Tap the brakes. Literally in my notes, it literally says tap the brakes right here. There, tap the brakes. Okay? Okay? So what we found was theta prime. We found what's called the reference angle. Okay? And the reference angle is the acute angle between 0 and 90 degrees formed by the terminal side of theta, and this is extremely important, and the horizontal axes. Reference angles always come off the horizontal x-axis. So important that we're going to star it. There's going to come a time that you're going to make your reference angle off the vertical. And I'm going to go like this. We started multiple times. Okay? So, just so you know, it always comes off the horizontal. So, now, let's talk each quadrant, because each quadrant has different rules. So, in quadrant number 1, my angle would be here. Theta prime is theta. I should say theta is theta prime. I put that in the wrong order, but I know I want to fix it because I'm OCD like that. Theta is theta prime. Quadrant 1 is the nice quadrant. Okay? Everything's all nice and pretty up there. Quadrant 2. See why I'm doing them in this order? Because that's where quadrant 2 would be. Okay. Quadrant 2, theta is here, theta prime is here. So what do you got? No. 180, because it's got to come off the horizontal. Yep. So theta here is equal to 180 degrees minus theta prime. Or pi minus theta prime. Because you might have radians too. Quadrant 3, there's theta, there's theta prime. So in quadrant 3, what do we have?
theta prime equals theta minus
Other way around. So theta equals 180 plus theta prime, or pi plus theta prime. And lastly, we have quadrant 4. There's my theta. Here's my theta prime. 360 minus theta prime. Or 2 pi minus theta prime. Okay? All right. So, I want you to find theta prime. First, let's do that first, and then we'll do our comparisons. Okay? I'll do number 1, and then you can do numbers 2 and 3. So number 1 has a 125 degree angle. So that means that this angle here is 125 degrees, which would mean then that theta prime is going to be 5 gets me to 130, 55 gets me to 180. So it's a 55 degree reference angle that I need to get to 180. Yes? And you find me the other 2 reference angles. Agree with me? First one, theta prime is 40 degrees. Second one, theta prime, my reference angle is 50 degrees. Yes? Okay. Now, this is going to require you and a calculator. Okay? But hold on, because I'm going to tell you what we're calculating. Actually, let me just get rid of this. Okay? So, I'm going to figure out what we're going to be calculating. So, how many do I got? 1, 2, 3, 4. I got 6. Perfect. Perfect. Okay. So, you 3 right here are going to calculate the sine of actual theta. Okay? Right? So you're going to figure out what the sine of 125 is, 220, and all that stuff. You 2 are going to calculate the sine of theta prime. Okay? Cosine of theta prime, U3. U4, cosine of actual angle. Okay? U2, tangent of actual angle. U3, tangent of theta prime. Okay? You guys, yep, sine, cosine, and tangent for my 3 levels. Okay? Go for it. Need a little more time? No? Good? Okay. All right. So, my sine of 125 degrees. What did you guys come up with?
0.8192.
What did you guys come up with for the sine of 55 degrees? So the same? Okay, all right. So sines are the same here. Okay. Cosine for 125. 5736. Cosine of 40. So
right? Okay, so cosine of theta okay. Tangent of 125. Okay, 1.43 tangent of 55.
I got 1 point.
1.43.
Yeah.
Yep. So opposites again. Okay. 220. Sine.
Negative 0.612.
6428. So opposites. Cosines. 0.7 or 0.76 ish. Ish. Same thing. Sames. Sames.
Ours negative.
Negative. Yours was negative.
Yeah.
Yours is positive. Negative. Still the same, but they're both negative, right? Yeah, still the same. You sure about that? What did you guys again? What did you guys get? And what did you get? Positive or negative? For 40 degrees? Yeah. No, they did 220. You were supposed to do 40. Yours, yes, that's what I say. They should be opposites. Okay, that makes better sense. They should be opposites. Tangents. Tangents.
No. 0.83.
So 0.84?
Yeah.
Yeah. So same, right? Yeah. Okay. That's the one that should be the same. Okay. 310. Sine.
0.760.
Same. Okay. Same signs. Sure. You guys should have negative, right? He forgot the negative sign. There should have been negative. Because it's a quadrant form. Yeah, so it should be opposites. Cosines. Same or opposite? Same. Tangents. Same or opposite? Why were the sines the same in quadrant 2, tangents the same in quadrant 3, and cosines the same in quadrant 4? It always got to do with the unit circle. What's positive? Where is sine the same And so in quadrant number 1, because all reference angles are in quadrant number 1, right? Because they're all acute. So if we took them out separately, they'd all end up in quadrant number 1. So everything's positive in quadrant number 1, right? What's positive in quadrant number 2? Y, which is sine. So that's why in quadrant number 2, the signs are the same. What's positive in quadrant number 3? Tangent's positive, okay? Which is why tangent was the same. And what's positive in quadrant number 4? Which is cosine. Exactly. Okay? Alright? Some thinking there. Alright. So, now, let's get into the meat of this stuff. This is why we had to learn all of that fun stuff. Okay? Because of the problem just like this. We are not on the unit circle. Right? I know that because 5 squared, or negative 5 squared plus 12 squared ain't 1 squared. Okay? Or is it 1, I should say. Okay? So we're not on the unit circle. We are broadening our horizon. We're coming off the unit circle, but we're using the same concepts through there. So in a problem like this, I would first, 1, figure out where I'm at. Okay? Where is the point, or what quadrant, excuse me, is the point negative 5, comma 12? Huh? Excuse me. Sorry, a hairball there. Quadrant number 2. So I'm up here. Right? Where this is 12 and this is negative 5. Right? Really it's 5. What we'll call it. What's the length of my blue segment? 13, right? Pythagorean triple. Okay? If it wasn't a Pythagorean triple, we'd have to use Pythagorean theorem, right? Okay? So we'd have to go so the sine of theta is right here, right? Sine of theta is going to be the opposite side, 12, over the hypotenuse, 13. Agree? The cosine of theta is going to be the adjacent side, negative 5, over the hypotenuse, which is 13. Nope, because we're in quadrant 2. Right? Cosine's negative in quadrant 2. So it's got to stay negative. Because we're in quadrant 2. Talk to me.
So, okay, so it's not like opposites, cosine stays negative.
Because we're in quadrant 2.
Okay.
Tangent. Negative 12/5. Right? Opposite, 12 over adjacent, negative 12/5. Yes? Okay? Now we just have to find theta. Okay? Well, here is my reference angle theta prime. Yes? Using my triangle here now. Okay? So now I'm going to break out this triangle. And this side is 12. This side is 5 now because I want to be positive. I want to be in quadrant number 1. I want theta prime to be an acute angle. So it's got to be, tangent's got to be positive. In quadrant 2, tangent's negative. That's why I don't use negative. Okay? I want my theta, my reference angle has to be between 0 and 90. So it's got to be in quadrant 1. Right? Tangent's got to be positive. And we also know that that's 13. Which trig function do you want to use? Use all 3 of them if we wanted to, right? Okay. We're going to default to tangent. Somebody with a calculator, if you would be so kind as to calculate for me the inverse tangent of 12/5. Oh, excuse me. Oh, I got the sneezes all of a sudden. 67 point. What do you say? 38013505. Okay. Which quadrant is actual theta? In quadrant 2, right? So what are my rules for quadrant 2 with reference angles? 180 minus. So actual, whoa, come on now. So actual theta, because I'm in quadrant 2, actual theta is 180 degrees minus theta prime. So 180 minus 67.38, let's say, would be 112 point, call it 6.2. Yeah, but 6.1, whatever. Yeah. And those, ladies and gentlemen, are the 4 answers that we were looking for. We needed to find sine, cosine, and tangent of theta, and we needed to find actual theta. Boom. There we are. Questions, comments, concerns, clarifications? Yes, ma'am.
Okay, so when I'm sine, cosine, and tangent, you use the coordinates.
You can make everything be positive if you want, but then you've got to remember, okay, in quadrant number 2, sine's positive, the other 2 are negative. In quadrant number 3, tangent's positive, the other 2 are negative. In quadrant number 4, cosine's positive, the other 2 are negative.
Okay, so if you're not memorizing anything, you could just use the coordinates.
But when you go to the reference angle, make everything be positive. Okay? Try it. Hypotenuse of this one? Of this triangle? 5. 3, 4, 5. Diagram triple. Get to know it. So then the sine of theta is going to be the opposite side over the hypotenuse, -4 over 5. Cosine of theta is going to be the adjacent side, -3 over 5. And the tangent of theta is going to be the opposite side, -4 over -3, which reduces down to 4/3. last thing we've got to find is actual theta. Well, we can find theta prime by taking the inverse tangent of 4/3. And you should get there then, or should have gotten that this was 53.1301025 degrees. Being that we are in quadrant 3, actual theta is 180 degrees plus theta prime. So 180 plus 53.1301 gets me 233.13 degrees. Questions, comments, concerns, clarification? So let's wrap it all up in a nice little bow. Okay? So in general, if theta is through a point x comma y, and r is equal to this, that's just the hypotenuse of the triangle that gets formed. Okay? Pythagorean theorem, x squared plus y squared equals radius squared. Square root both sides, you get the square root of x squared plus y squared. Okay? So if that's the case, then in all of these, sine of theta is going to be y divided by r. Cosine of theta is going to be x divided by r. Whatever the x is, no dropping of any. Tangent is going to be y divided by x. Now the nice thing is, the other three are just reciprocals of those. So this would be r divided by y, r divided by x, and x divided by y. And here's the cool thing. The reference angle is always going to be equal to the inverse tangent of y divided by x. But the kicker is you need to drop any negatives. Okay? So it's just absolute values. Okay? Because then that puts theta prime back into quadrant number 1. Okay? Then, if it's in quadrant 1, theta is theta prime. If it's in quadrant 2, theta is 180 minus theta prime. If it's in quadrant 3, it's, oops, I should say theta first. Theta is 180 plus theta prime. And if it's in quadrant 4, theta is 360 minus theta prime. So what I'm handing out to you now, or what's being passed out to you right now, is the 4.3b reference angles worksheet that I referenced earlier in class today.